Hi, I'm going to discuss my solution to the LeetCode problem rotate list. It's today's problem in the October LeetCoding challenge. And I'm Channa Bankapur. I'm a trainer at GoMaster Technologies, and this video is being recorded for the YouTube channel of GoMaster Technologies. Please do subscribe to it. The, the problem is as follows. We have a linked list. We need to rotate the list to the right by k places, right? And we have a couple of examples. Let's try to understand how does it look like. So we have this first example where we have for 5 elements, 1, 2, 3, 4, 5, right? It's a linked list, right? So with the last one is going to be pointed to null. So this is the input essentially. Now if k equal to say, let me just work out for a few cases they have given for k equal to 2. If k equal to 1, when we rotate right by 1, so we are going to have 1, 2, 3, 4 here, and 5 is going to wrap around and then come to the beginning. And if k equals to 2, we are going to have 1 right shifted by 2 positions, so it's going to be 1, 2, 3, and 4 and 5 are going to be wrapped around here, right? Let me show for a couple more examples here so that we can generalize the idea. So for k equal to 4, 1 is at the end, and then 2, 3, 4, 5, right? Now, if you observe what happens in this case. So these are the only 4 possible cases. If k equal to 5 or 0, they are essentially same, and we don't have to do anything. If k is greater than 5 also, all we need to do is take, if n is the length of the list, it's going to be k mod n. K mod n. So this is what we can actually assign k to. So that way we can only worry about these cases which are in the range of 1 to n minus 1, right? So let's see what happens in these cases. So when k equal to 1, we need to basically make this last node, fifth node, as the head of the new list. When k equal to 2, the last but one node is going to be the head, and k equal to 3, the third from the last, and then fourth from the last, right? So we need to basically figure out where it is present in the end. So maybe if I can get hold of, say when k equal to 1, if I can get hold of this node 4, that's going to be the new tail. So if I can get hold of the new tail, I can get the new head and also I can make new tail point to null, right? So that helps me, and that is at a distance of 4, right? And so that is when k equal to 1. When k equal to 2, we need to get hold of the new tail, which is going to be 3, so which is here, which is 3 nodes away, and k equal to 3, it's going to be 2. So in other words, I think I need another variable, more like m equal to n minus k, which gives me the position of the new tail, and that helps me to get the new head and new tail both, right? So that's the method I'm going to use. Let me quickly code that. Okay, so I already coded here. Say head is the no, head of the linked list, and so when head is null or head of next is null, that means there are only 0 or 1 nodes, one node in the list, and in that case there is no point in rotating. So I'm gonna just return that. So that actually rules out these basic cases. So after that I'm going to find the length. So length is going to be at least 1. So I'm starting with 1, and then and tail is pointing to head at the moment. And as long as tail dot next is not equal to null, I keep incrementing it. And the number of times that increments is going to be n is going to increment along the same lines. So now I have basically a pointer to the tail of the list and also length of the list, right? So why do I need tail of the list? Because we need to point to head of the list, right? When we rotate it, right? So now I'm going to take that in a k equal to k mod n in this case. And if k equal to 0, then there is nothing to be done. So I handle that case here. And after that, so now we know that k is going to be in the range of 1 to n minus 1, right? So that means it has to be rotated in some way, right? So I'm going to find this m is n minus k. So this gives me the mth node is going to be the new tail, right? So this is how I'm going to find the new tail. So new tail to start with, it is going to be head. That is the first node. and so I'm going to keep reducing m, so that I'm going to find the mth node. So every time I'm incrementing the new tail. So when I come out of this one at line number 21, before that, uh, new tail node is properly pointed. Now I'm going to get the new head. So new head is just the next of the new tail. And then new tail is going to become is going to point to null, because it should point to null. It's a null terminated linked list. And this is also we need to do without forget. So the older tail dot next should point to head, because it is rotated essentially, and then return the new head, right? So I think this is all we need to do. So let me run for a test case they have given. Yes, it works. So for this test case, with 5 nodes in the linked list, and 2 is the rotation, we need to rotate by 2 places in this case, and we get the right answer. And let me submit it, and it is accepting. Right? So if you look at the time complexity, it's very clear. We have basically n iterations here, and then the number of iterations we do here is going to be equal to that m, and after that there is nothing to be done. So m is also within n, so it's not the total number of iterations are lesser than or equal to 2n. So that's why the time complexity is going to be linear. All right, and we didn't take any other place. We just moved the nodes around. Right, it's a linear time constant space solution. All right, so yeah, if you have any other solutions, or if you have any comment suggestions, please put them down in the comments. All right, thanks for watching. Keep coding.